Hey guys, it's Off51 here, and today we're going to be solving non-overlapping intervals. In this problem, we're given an array of intervals where each interval represents a start time and an end time, and they want us to return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. So what does this mean exactly? Well, first let's start by defining what an overlapping interval is. In this problem, an overlapping interval is only if let's say we have an interval here going from 1 to 3, and we have another interval going from 2 to 4. This would be considered an overlapping interval because this 2 interferes with this interval here. In previous interval problems, if you had an interval that went from 1 to 2 and another one that went from 2 to 3, then it would be considered overlapping because they overlapped here. But for this problem, this scenario here is not considered overlapping, so that's just something important to take note of. So now that we understand what an overlapping interval looks like, let's try and come up with a solution. So first things first, we're going to have to sort this intervals array here because if you remember the last problem, there was no faster way to compare intervals without them being sorted. So our algorithm is already going to be n log n time. So now we have our intervals list sorted and we can start comparing them. And we're going to have a previous pointer pointing here and a current pointer pointing to the second interval. And we check, are these intervals overlapping? Well, let's take a look. This first interval here ends here and the second interval starts here. So that means there is overlap. And as you can see in the problem, they want us to return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. So we have a choice here. Do we remove this interval or do we remove this interval? Well, as you can see, this 1 and 3 interval overlaps with 2 intervals. So if we were to remove just this one here, there would be no overlap between the rest of the intervals. But if we remove this interval here instead, we'll get another overlap over here. And we would have to remove 2 intervals in the end to make them non-overlapping. So in the end, we want to remove this interval because this way we would only need to remove 1 interval, so the rest of the intervals are not overlapping. If we remove this one, then we would have to remove 2 at the minimum. For example, we would have to remove these 2 so that they're not overlapping. So how can we define that in the code? Well, as you can see, this interval has a later end time than this one. So we can just say we want to keep the interval with the lower end time and delete the one with the bigger end time. This way we have a lower chance of having more overlapping intervals. So for this example here, let's say we actually deleted this interval here. Well, now we don't want to move the previous pointer to this one, we just want to move the current pointer to the next interval. And now we would check if these 2 intervals overlap, and clearly they don't, so we would just move our current pointer again. And then we also want to move our previous pointer to the one we're just currently looking at, since there was no overlap there, and that would be our latest interval. So now for our last iteration, we check if these 2 intervals overlap. And as you can see, they don't overlap. So in the end, we would just return that we deleted 1 interval, and that is correct here, as you can see, and that's basically the whole algorithm. Our time complexity for this is going to be O of n log n, because we have to sort the array, and we're also going through it once, and that would just simplify to O of n log n, and our space is going to be constant, because we're only using a variable to keep track of how many intervals we've deleted. And now that we have that, let's get into the code. To start, we want to sort our intervals array by start time, so we can just do intervals.sort in Python, and that should sort it by start time. Next, we want to initialize our count variable, and this is going to keep track of how many intervals we deleted. We don't actually have to delete them, we just have to keep track of how many we should have deleted. Next, we're going to initialize our previous pointer, but we actually only need the endpoint because that's what we're comparing. So to start is going to be the interval at the start, and we're going to take the endpoint of that and just store it there. Next, we just want to iterate through the rest of the intervals. So we're going to do for I in range starting from 1 all the way to the end of the intervals list. And now we're going to check if there's overlap. And the way to check that is do if the previous end is greater than the current interval start time, then that means there's an overlap. So as soon as we have an overlap, we're going to increase our count by 1. And next we're going to update our previous end to be equal to the minimum between our current previous end and our current interval's end. So this way we're guaranteed to have the smaller interval, which means we're going to have less overlaps. So if there's no overlap, all we want to do is update our previous end to be our current interval's end. And then at the end, we can just return our count. And that should work. So as you can see, this code is pretty efficient. And now I'll go through the code manually. So here I've just redrawn the example from the problem that we've been doing. And it's already in sorted order, so we're good here. And I've also initialized these 2 variables to what they should be. So our count is 0, and our first interval's endpoint is 2. So this is also done. And now we just iterate through our intervals array starting from this index here. So let's see, do these intervals overlap? Well, our previous end is 2, And the start time for our current interval is going to be 1, so that means there is overlap. So we're going to increase our count by 1, so now we have 1 interval deleted, and our previous end is going to be updated to the min between our current value or our current interval's end time. Our current interval's end time is 3, and the previous end is still 2, so that would be the minimum, so we keep it as 2. So now we go to our next interval, which is going to be 2 and 3. So let's see, is there any overlap? Our previous end is 2, and that is not greater than the start time of our current interval, which is also 2. So instead, we just update our previous end to be the end of our current interval, so that's going to be updated to 3. And now we take a look at our last interval, which is 3 and 4, and we check if there's overlap. Our previous end is 3, and that is not greater than the start time of our current interval, which is also 3. So we're just going to update our previous end to be the endpoint of our current interval, which is 4. And now we're done going through our intervals list. So in the end, we just return our count, which is 1. And that is correct. We only deleted this one interval up here, which was 1 and 3. And that is the minimum amount of intervals we can delete so that the other intervals are not overlapping. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.